Hey guys, so now we're going to talk about the scientific method. This is the first part of our little review section. So we should have all heard about the scientific method by now. Depending on who you talk to or where you go and read, sorry, I'm adjusting my blanket. It could be worded differently. It could have extra steps. It could have less steps. But the scientific method is generally just a set of steps or methods that we use to figure out something in science. And you literally do this all the time. Like, you may not like sit down and write out a hypothesis or draw conclusions or do an experiment, but you go through this thought process in your head all the time. So you could wake up and you're like, oh, it's snowing outside. Well, if it's snowing, my feet may get cold or wet, so I should wear a specific type of shoe. Or like you think like this all the time, you just don't necessarily break it down. So the scientific method is just something that we use to make decisions or figure something out. So a method, it's a set of steps used to solve a problem or answer a question. So again, in your notes, the blanks are going to be these different colored words. So this is the general set of steps that we're going to go over for earth science. I've changed some of the wording because as science continues to grow, we kind of change some things. I don't really want to use the word guess, so I've taken that out of these steps. And it's fine if you say guess or anything like that, but I'm going to try to steer clear from saying that because it's not necessarily an educated guess. You actually look up information and do research before you make a statement. So let's go back to the first step. The first step is you're going to look around, you're going to observe, you're going to see what's around you to fit. Like, you just don't want to make up willy-nilly questions or statements without actually looking around. So the first step is to observe. The next step is to ask a question. So you see something, you're like, oh, that's weird. Let me make a question about that. So your second step is to ask a question. It could be multiple questions, but to test something, you just need one specific question, and then you'll go on and test it. So you got to look around, you got to observe, you got to ask questions. The next form is to collect information or data. There's lots of different ways to do this. This can look like researching, this can be looking at other people's experiments, this can just be asking for information from people. But you need to collect data before making a statement or forming your hypothesis. So, step 4 is to form a statement based on your info that you collected. And this statement is going to be your hypothesis. Most people will see this in an if then format. So, like, if this happens, then this will happen. That's kind of the general hypothesis statement. So after you form this statement based on the information you've collected in step 3, you're going to test your hypothesis to see if what you were originally thinking was correct. So you're going to test this through an experiment. So going back to the shoe thing, you observe that, oh, it's snowing outside. Your question could be, will my feet get wet? It's like, and then you're going to do some data collecting, maybe, ask your siblings or a friend, like, hey, what type of shoes are you wearing? Then for your statement or your hypothesis, you could say, if I wear my snow boots, my feet won't get wet. So you're going to test that. That would be your experiment. That would be you putting on your snow boots and going outside and seeing if your feet get wet. Oh, my little bubble moved. Okay. So once you do the experiment, the next thing is to draw conclusions. So based on your results of your experiment, your statement will either be right or wrong. So after you come back inside, after you've worn the snow boots outside in the snow, your conclusions will be based on if your feet were wet or not. So if your feet were not wet, they stayed dried, you would support your hypothesis. You would say that you were right. And then you would share that result. You'd be like, hey guys, these snow boots actually work. My feet are dry. That's kind of just a very simplified version of how to use a scientific method. So we kind of go through this, like I said earlier, every day in our mind. But it can be more scientific, and it can be more difficult. The data can be a bunch of numbers. You could have to repeat your experiment several times. So let's say you had a faulty pair of snow boots and they came with a hole in them. You would have to get another pair of boots and redo the experiment. So like it's okay to be wrong. That's fine. But sometimes you just have to keep doing the experiments. But you still share that data like, hey, my feet did get wet this time, but it's because there was a hole in the boot or in the shoe. So that's the rundown of the basic method. And like I just said, it's not bad to be wrong. Most of science is learning what's not right, what doesn't work. So if you're wrong, it's fine. You learned what didn't work, and then you redo the whole method. And a good example for this is like disease research. So, like with vaccines, you try something, if it doesn't work, you try another. Or just with normal medications, like if you have a cough, try this to treat it. If that doesn't work, try this. It's okay to be wrong because it eliminates that possibility. So, that should be the first part of your notes there. So, a controlled experiment. It's important to know what these are. So, the example that we're going to use for the next couple slides is this people with a cold. So, how do you test to see if a new cold medicine works? You give it to people with a cold. If they get better, it works. But it's not necessarily that simple because people are different. People's colds are different. They could have different colds. Like, it's not all the same. Or they could just get better because it wasn't really cold, or they have a really strong immune system. So, you want to have a controlled experiment. And this type of experiment is like the go-to. So you're going to get a bunch of people who have the cold. First, they need to have the cold to see if this medicine works. And you're going to have two groups. One's going to be an experimental group who will get the medicine or who will have the independent variable placed on them. And then the other group is the control group. So they think they're getting the medicine, or they think that the independent variable is being used on them, but it's not. They get a placebo. So it's like if you and your friend are both sick, you're like, oh, I'm sick. And you're like, and I give you both this medicine. I tell you it's the same medicine. I hope you get better. One of you truly gets better, and the other one, you can get a little bit better, or you could get better, but I've not given you the real medicine. So if you don't get better and you get the placebo, and the person that got the actual medicine gets better, on a larger scale, I could say, oh, the medicine works because the people that got the medicine got better. But a placebo, it can cause a placebo effect, so it's like psychological. So if you think you're taking medicine, your brain could trick your body into getting a little bit better. But generally, the control group will not get the actual medicine. It will not have the independent variable placed on them. So, and this is so you can compare. So you want one group that you've manipulated, and you want one group that you've not manipulated. So that brings us to the types of variables. I've kind of already mentioned a couple of these. It's very important to know the difference. So independent variables, or the medicine that we gave, are the things that you test, the thing that you manipulate or change. And then, oh, sorry. Let me scroll on the notes. Yeah, so this is what you're testing, this is what you're changing, this is what you're manipulating. The dependent variables are what you measure. So in this case, it's the time it takes for a person to get better. It depends on the independent variable. So it's what you're measuring. It's what changes because of the independent variable. It's like, so your independent variable is this, and this happens because of that. And then there's another type of variable called a controlled variable. And these are things that you intentionally do not change. So it's like if this was a different example, if we were growing plants and we wanted to test to see if different amounts of water change the amount of growth. So if we're just changing the amount of water, we have to keep the sunlight the same. We have to keep the soil the same. We have to keep the type of pot the same, the type of plant. All of those things have to stay the same. So they're the controlled variables. And you are only changing in one thing, which is the amount of water. So in the PowerPoint, there's not the controlled variable, but I added it to your notes because that's going to be important for the activity. And then just another thing to add in, especially in the space thing, I'll talk about theory sometimes. This necessarily won't be in your activity, but most of the things we discover with multiple experiments and doing science, they're theories. But it's not, you can't just say, oh, it's only a theory, because theories are as close to certain as science can come. So, whenever you're going through the scientific method, you would say that your experiment results support your hypothesis or it doesn't support. You can't say, oh, it proves this is right, but it's as close, like repeated experiments, it gets you as close as possible to being certain because science is always changing. So a theory is still very important. It's not necessarily 100%, but it's like 99.9. It's like right there. So that's just a little side note. So whenever you're doing your activity, you will want to make sure you understand the difference between the variables and what makes an experiment a controlled experiment and the two different groups within that. And that's broken down in your notes. Go ahead and try the activity. I think I made the copy to where you have your own copy and you can just type in that. But if you want to write on paper to answer the questions, you're more than welcome to do that. Just make sure you label it like 1, ABC, 2, ABC, stuff like that. Okay, so that's a scientific method. Again, that should be a review. You should already know that. And please email me if you have any questions about the activity. Bye, guys.